Hi, my name is Dr. Adum Babu, Associate Professor of EC Department. In this lecture, we'll discuss about the various definitions of probability and theorems of probability. So, today we will discuss the first topic of today's lecture is classical definition of probability. How we will define the probability of any event. So, in any experiment, we will define the probability by using the events. By using classical definition of probability, the probability of any event is n by s. N is the total number of events which is favorable to a particular event A, and s is the total number of events of any experiments. So in this classical definition of probability, total number of events S may be equally likely or mutually exclusive events. Suppose consider this example. A fair die is rolled. What is the probability of getting a number 6? If a die is rolled, the total number of events are 6. 1, 2, 3, 4, 5, 6 events. So it is having the 6 spaces. So we are getting the 6 mutually exclusive and equally likely events. So my probability is getting a number 6. Out of 6 events, probability of getting number 6 is only 1. So events favorable to this particular event is 1. So the probability of getting number 6 is equal to 1 by 6. Similarly, one more example for classical definition of probability is a fair coin is tossed twice. What is the probability of getting 2 heads? If 2 coins are rolled or 1 coin is tossed twice, the possible outcomes are 4 only. So head, tail, head, and tail. These are the 4 possible outcomes of this experiment. So I would like to find out the probability of getting 2 heads. Out of these 4 outcomes, probability of getting 2 heads are only 1 outcome is there. So probability of getting 2 heads is nothing but favorable events is 1 out of 4 events. That means probability of getting 2 heads is 1 by 4. The main limitation of this classical definition of probability is this classical definition of probability is applicable to only finite number of outcomes only. But we are having some experiments, we are having infinite number of outcomes, but this is not applicable to the infinite number of outcomes, and all the events are mutually exclusive and equally likely. Some experiments events are not equally likely and mutually exclusive events. So these are the major limitations of classical definition of probability. This is a one type of approach to define the probability. Next approach is relative frequency definition of probability. By using relative frequency, we will define the probability. Here, consider one experiment E is repeated n number of times. In that experiment, I am defining the 2 events A and B. Experiment is repeated n number of times. Among n repetitions, event A is coming NA number of times, event B is coming NB number of times. Suppose experiment is repeated 10 number of times, event A is coming 4 times and event B is coming 6 times. So the relative frequency of event A is 4 by 10. That means the relative frequency of event A is equal to NA by N. N is the total number of repetitions. NA is the event A is occurring among n repetitions. So the relative frequency of f of A is indicated by NA by N. Similarly, FB is NB by N. So this is the relative frequency division. Then how we will define the probability by using relative frequency approach? As n tends to infinity, that means if the number of repetition tends to infinity, if I am repeating the experiment an infinite number of times, then this relative frequency value approaches to probability value. By using this formula, we will define the probability by using relative frequency approach. As n tends to infinity, that means limit n tends to infinity, NA by N value approaches to the probability of a particular event. This is the relative frequency definition of a probability. The major limitation of this relative frequency approach is it will give the only approximate value. In relative frequency gives the approximate value. It will not give the exact value of the probability. Whereas in classical definition of probability, it will give the exact value of the probability. Next approach is axiomatic definition of probability. Here mainly we will discuss the three axioms, axiom 1 and axiom 2 and axiom 3. Axiom 1 is always the probability value of any event lies between 0 and 1. If the event is occurring, the highest probability is equal to 1. If the event is not occurring, the highest probability is equal to 0. Thus, the first axiom defines the probability of any event of any experiment lies between 0 and 1. Next, the second axiom is the sum of probabilities of all events in any experiment is equals to 1. In any experiment, it is having the n number of events. The probability of all those events, the sum of probabilities of all those events is equals to 1. That is the second axiom. The third axiom is if A and B are any two mutual exclusive events, then P of A union B is equal to P of A plus P of B. First of all, mutually exclusive events means happening of one event prevents the happening of all the remaining events. Two events mutually will not occur. So one event is occurring, another event will not occur. These two events are said to be mutually exclusive events. Happening of one event prevents the happening of all the remaining events. So jointly these two events cannot be occur. So P of A intersection B value is equal to 0. That means if A and B are any two mutually exclusive events, then P of A union B is equal to the sum of their individual probabilities, P of A and P of B. Axioms will not define probability. Axiomatic definition will not define the probability, but these axioms gives the restrictions to assign the probability of any events. The first two approaches, classical definition of probability, relative frequency approach, defines the probability. But whereas axiomatic definition of probability will not define the probability, it will give the restrictions to assign the probabilities of any event. To define probability of any event, the conditions must be defined by the axioms. These are the three different approaches to define the probability. Next one is addition theorem of probability. There are different theorems in the probability: addition theorem, multiplication theorem. The first theorem is addition theorem of probability. If A and B are any two events, then P of A union B is equal to P of A plus P of B minus P of A intersection B. This is the addition theorem of probability. The example of this addition theorem of probability is: two dice are thrown. Find the probability of sum of numbers on two faces is divisible by 3 or 4. So you have to find out the probability of sum of numbers on two dice that is divisible by 3 or 4. So I am assigning the two events. Event A is equal to sum divisible by 3. Event B is equal to sum divisible by 3. If two dice are thrown, the total possible outcomes is equal to 36. The first one is sum divisible by 3. So here I am having the out of 36 sample points, I am having the 12 sample points. The sum of 2 points, first point is equal to 1 plus 2 is equal to 3, that is divisible by 3. Next one is 1 plus 5, 6, that is also divisible by 3. 2, 1, 2, 4, 3, 3, 3, 6, 4, 2, 4, 5, 5, 1, 5, 4, 6, 3, 6. All these 12 points, sum is divisible by 3. So probability of sum divisible by 3 is equal to P of A is equal to total points is equal to 36. Out of 36 points, 12 points sum is divisible by 3. So probability of event A, that is nothing but sum is divisible by 3 is equal to 12 by 36. Similarly, event B, probability of sum divisible by 4. Here out of 36 sample points, I am having the 9 sample points. So 1, 3, 2, 2, 2, 6, 3, 1, 3, 5, 4, 4, 5, 3, 6, 2, 6, 6. So these 9 sample points sum is divisible by 4. So out of 36 sample points, sum of points divisible by 4 is 9 points. So the probability of sum divisible by 4 is equal to 9. the intersection of these two sample points, I am having the only one sample point, that is 666. So A intersection B is equal to 66. P of A intersection B is equal to 1 by 36. So we have to find out the probability of getting sum divisible by 3 or sum divisible by 4. That means P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A is equal to 12 by 36, P of B is equal to 9 by 36, P of A intersection B is equal to 1 by 36. That is the final answer is 5 by 9. So by using addition theorem, we will find out the probability of getting sum divisible by 3 or sum divisible by 4. This is one example based on addition theorem. Next one is conditional probability. How we will define the conditional probability? Here I am having the two events A and B. A is conditioned by B or B is conditioned by A. Here the probability of A occurs given that the event B has already occurred. That means event B occurred first. After that only A is occurring. That is the conditional probability P of A by B. So P of B by A means event A occurred first. After that B is occurring. That means B is conditioned by A. Here also A is conditioned by B. That is called condition probability. If one event is conditioned by another event, that is said to be conditional event. Similarly, the probability of happening of one event conditioned by another event is said to be conditional probability. P of A by B is equal to P of A intersection B by P of B if P of B is not equals to 0. The proof of this conditional probability is based upon the set theory. N of A by B is equal to N of A intersection B by N of B. Divide and multiply by N of S. N of A intersection by N of S will becomes P of A intersection B. N of B by N of S gives the P of B. So that is the proof of the conditional probability. Next we will discuss the one problem on conditional probability. Here in this problem, a dice is rolled. If the outcome is odd number, what is the probability that is prime? If one die is rolled, the total possible outcomes are 1, 2, 3, 4, 5, 6. Out of those 6 sample points, my event is equal to B is equal to event of getting odd number. Out of 6 sample points, odd number sample points are 1, 3, 5. Next, A is the event I am defining as a event of getting prime number. So sample space of event A is equal to 2, 3, 5. These are the prime numbers out of those 6 sample points. Next, A intersection B is equal to, I am having 2 sample points, 3, 5, 3, 5. So probability of A is nothing but probability of getting prime number. I am having the 3 prime numbers out of 6 sample points. That means P of A is equal to 1 by 2. Next, probability of B is equal to probability of getting odd number. Odd number is also I am having 3 by 6, 1 by 2. P of A intersection B is equal to 2 by 6, that is equal to 1 by 3. I have to find out the probability of getting prime number P of A by B. What is the probability that it is prime? So first prime number event must be happened. After that only I am taking the odd number. So P of A intersection B by P of B, that is equal to 1 by 3 by P of B is equal to 1 by 3, that is equal to 2 by 3. This is the one of the example of conditional probability. One more example of conditional probability is here. One more example. So I am having the 50 tickets. In that 50 tickets are numbered from 00 to 49. What is the probability that sum of digits on the selected tickets is 8 and product is 0? Sum is 8 and product is 0. Here I am defining the two events, event A and event B. Event A is equal to sum of the digits. Event B is equal to product of the digits. Here I am having the sample space which is having the product is 0. Product of the two digits is 0. For event B, I am having these number of tickets 00, 01, 02, 03, 04, 05, 06, 07, 08, 09, 10, 20, 30, 40. So I am having the 14 ticket numbers. The product of two digits is equal to 0. So P of B is equal to 14 by 50. Next, out of these 14 digits, sum is equals to 18 means 8 means I am having only one number, that is 0 comma 8. P of A intersection B is equal to 1 by product is equal to 0 and sum is equal to 8. Then I have to find out the P of A by B. P of A by B is equal to P of A intersection B by P of B. This is from conditional probability. A intersection B is equal to 1 by 50, 14 by 50. That is equal to 1 by 14. This is based upon the conditional probability. We will solve this problem. Next one is multiplication theorem of the probability. If A and B are any two events, then P of A intersection B is equal to P of A into P of B by A or P of B into P of A by B. This is the multiplication theorem statement. If A and B are any two events, then P of A intersection B is equal to P of A or P of B given that A has occurred. This is also condition probability. After occurrence of A only, B is occurring. Here, after occurrence of B only, A is occurring. So here, suppose two events are independent. That means A comma B events are independent. In this expression only, if two events are independent, that means A did not depends upon the B, B did not depends upon it. There is no relation between event B and event A. Then P of B by A becomes P of B. P of A by B becomes P of A. If there is no relation between A and B events, both those events are independent events. If A and B are independent, then this conditional probability becomes the product of individual probabilities. Why? Because here B did not depend upon A did not depend upon B. Then P of A into P of B by A becomes P of B. P of A into P of B. This is the multiplication law of probability for independent events. For any two events, the multiplication theorem P of A intersection B can be written as P of A into P of B by A. For independent events, the multiplication theorem is P of A intersection B is equal to P of A into P of B. Now we will solve some problems on the multiplication theorem. The first example is a bag contains 6 white balls and 9 black balls. 2 balls are drawn at succession without replacement. What is the probability that the first ball is white and second ball is red? So here the bag consists of 6 white balls and 9 black balls. Total number of balls is equal to 15. 9 plus 6 is equal to 15 balls I am having. So in the first draw I have to take the white ball and second draw I have to take black ball. But white ball is not replaced. So here I am having the two events. I am assigning the two events. A is the event of getting white ball in first draw. B is the event of getting black ball in second draw. First I am taking the one white ball from the bag. So out of 6 balls, I am taking the only one white ball. That means 6C1 by 15C1 is the total number of balls. From total number of balls in a bag, I am taking the one ball. That means 6C1 by 15C1. After taking the white ball, I am taking the black ball. This event is happened. In the first draw, white ball has taken. In the second draw, I am taking the black ball. One ball is already taken. That means 15 minus 1, 14 balls I am having in the bag. So out of 14 balls, I am taking the one more ball. That is the one black ball. Black balls is 9. Out of 9 black balls, I am taking the one black ball. Our total number of balls is equal to 14 balls. So probability of drawing black ball after drawing the white ball is equals to 9C1 by 14C1. So probability of getting white ball in first draw and black ball in second draw. That means P of A intersection B. White ball in first draw, black ball in the second draw. This is the first draw. I am taking the white ball. Second row, I am taking the black ball. From multiplication theorem, P of A intersection B is equal to P of A into P of B by A, or P of B into P of A by B. P of A is equal to 6 by 15. P of B by A is equal to 9 by 14. That is equal to 9 by 35. So first, we have to draw white ball. Next, we have to draw the black ball. From multiplication theorem, we will solve this problem. So this is the one more example based on the multiplication theorem. A missile can be accidentally launched if two relays, both A and B, have failed. The probabilities of A and B are failing are known to be 0.01, 0.03. It is also known that B is more likely to be failed with probability 0.06 if A has failed. What is the probability of accidental missile launch? What is the probability A will fail if B has failed, or A fails, B fails are statistically independent? Here, when the missile will be launched means if two relays have failed, then only missile will be launched. So probability of relay A is equal to 0.01, probability of failing relay B is equal to 0.03. So missile can be launched if two relays are failed. That means P of A intersection B. And also we are having one more value. B is more likely to fail if A has failed. That means first A event is occurred, after that B is occurred. B is more likely to fail if A has failed. Already this event is happened, after that only event B is happening. P of B by A is equal to 0.06. So from the multiplication theorem, P of A intersection B can be written as P of A into P of B by A, or P of B into P of A by B. So P of B by A is 0.06. B is more likely to fail if A has failed is equal to 0.06. P of A fails is equal to 0.01. That means 0.06 into 0.01 is equal to 0.006. So probability of missile launch is, if two relays are failed, then missile will be launched. P of A intersection B is equal to this one. Next, B bit is, what is the probability A will fail if B has failed? That means P of A by B. This is conditional probability. P of A intersection B by P of B. P of A intersection B already we calculated 0.0006. P of B is probability of relay failed. B event relay is failed is equal to 0.003. That is equal to 0.002. Next, third one is the A and B are events are statistically independent events. If P of A intersection B is equal to P of A into P of B, then A and B are events are said to be statistically independent. If two events satisfies this condition, P of A intersection B is equal to P of A into P of B, then only A and B are said to be statistically independent events. Here, P of A is equal to 0.001, P of B is equal to 0.003, 0.003, 0.001 and 0.006. Here, this condition is not satisfied, then A and B are said to be not statistically independent. So first problem we will solve by using multiplication theorem. Second problem is we will solve by conditional probability. Third bit we will solve by multiplication law of probability for independent events. So these are the main theorems, that is the addition theorem and the multiplication theorem and the conditional probability in the probability. This is about this lecture. So in this lecture mainly we discussed about the different definitions of the probability: classical definition of probability, relative frequency, and axiomatic definition of probability, and theorems of the probability: addition theorem, multiplication theorem. Thank you.